So there are two correct answers. The third one and the fifth one. And this is why a hash table is such a great advance over the linear index, is that we can double the number of keywords and double the number of buckets, and the lookup time stays the same. With the linear index, if we double the number of keywords for each lookup, we need to go through that loop once for each keyword. If the keyword was near the end or one that wasn't in the table, the time to look up the keyword would double as we double the number of keywords. With a hash table, if we also double the number of buckets when we double the number of keywords, well, then the number of keywords in each bucket stays the same. So we're dividing the keywords evenly between buckets. So this is the number of keywords per bucket is the number of keywords divided by the number of buckets. If we double both, that number stays approximately the same. The time to look up only depends on the number of keywords per bucket. The time to find the bucket is very fast, right? We just need to run the hash function, find that element of the list. Both of those don't depend on the size of the list, how long it takes to do that. And then we have to look through that bucket, the size of the bucket, we have to look through each element in the bucket one at a time. So if we keep the number of keywords per bucket the same, the lookup time stays essentially the same. So that's the great property that hash tables have. If we double the number of buckets as we double the number of keywords, the expected lookup time doesn't change. For the other possibilities, well, if we double the number of keywords and keep the same number of buckets, that's going to get slower because the number of keywords per bucket will approximately double. So it's going to take about twice as long for each lookup. If we keep the same number of keywords but double the number of buckets, well, then it's going to actually get faster. We'll have the same number of keywords, double the number of buckets. So this value will be approximately half what it was before. The expected lookup time will be about half what it was before we doubled the number of buckets. If we have the number of keywords keeping the same number of buckets, well, that has essentially the same effect. The average number of keywords per bucket will be half what it was before. So the expected lookup time will be about half what it was. And finally, if we have both, well, that's going to keep the ratio the same. So the expected lookup time will be about the same. So that's why these two are the correct answers, that those are expected to leave the lookup time essentially unchanged.